Hello everyone, this is your course instructor Harshita. So in this session, we'll be studying about Shannon Fano ternary code. So under this type of decoding, we'll be following some three steps. So what is the first step is, we'll be arranging the symbol probabilities in descending order. Next, after arranging the probabilities in the descending order, these set of probabilities are further divided into three groups. So how do we decide the dividing of the groups based on what decision is that the sum of probabilities in each group should be approximately equal. So why do we divide it into three groups only? As the name itself indicates, ternary code. Hence, we'll divide it into three groups. Okay. After dividing it into three subgroups, we will assign three values to each of the three subgroups. So, what are the three values that we'll be going to assign is 0, 1, and 2. So after arranging the probabilities in descending order, and then we have to subdivide it into subgroups. After dividing it into subgroups, we will assign three different values to each of the three subgroups. So we will continue this subdivision until no further subdivision is not possible. Okay, so we'll go on repeating these steps until further subdivision is not possible. So in order to understand this type of decoding, let's consider an example here. So the question says, construct a Shannon-Fano ternary code for following messages and find code efficiency and redundancy. Also draw the code tree and find probabilities of zeros, ones, and twos. So this is a symbol set S1, S2, S3, S4, S5, S6, and S7, and the probabilities are given as 0.3, 0.3, 0.12, 0.12, 0.06, 0.06, and 0.04 with the values of x equal to 0, 1, and 2. Okay, so these are the values of the symbol probabilities given. So what is the first step that we do? We'll arrange the probabilities in decreasing order, isn't it? So first step is arrangement of probabilities in decreasing order. So you can see 0.3, 0.3, 0.12, 0.12, 0.06, 0.06, and 0.04. We have arranged it in decreasing order, and then we will have to go for subgrouping. So how will we go for subgrouping? We will group it in such a way that the sum of the probabilities in each group is approximately equal. All right. So this 0.3 and 0.3 is equal. So let's add these five values, that is 0.12, 0.12, 0.06, 0.06, and 0.04. So after adding these five values, you will find that the sum will be equal to 0.4. So this 0.4 is approximately equal to 0.3, isn't it? So we will go for subgrouping these five elements. Okay, and this 0.3 will form a subgroup 1, and this second 0.3 alone will form subgroup 2, and these five elements together will form subgroup 3. So after dividing it into three different subgroups, we are supposed to assign three values, that is 0, 1, and 2. The first subgroup is assigned with the value 2, second subgroup is assigned with the value 1, and the third subgroup is assigned with the value 0. So I'll be assigning 0 for all the elements in the subgroup 3. Okay. After this, what am I supposed to do? I'm supposed to repeat the steps, whatever I performed previously. So again, I should go for subgrouping. I have 0.12, 0.12, 0.06, 0.06, and 0.04. Here no further subgrouping is possible as only one element is there in this subgroup 1, and here also similarly in subgroup 2 there is only one element, that is 0.3. There is no further subgrouping possible over here, so I will leave it as it is. What I can divide it into subgroups is this subgroup 3, so I'll consider that. So you can see 0.12 and 0.12 I have here, and let's add these three values and find out which value we'll get. So we have 0.06, 0.06, and 0.04, isn't it? So we'll be getting 0.12 plus 0.04. that is 0.16. So this 0.16 is approximately equal to the other 2.12, isn't it? So we will divide the subgroup like this. This 0.12 will form subgroup 1. The second sub 0.12 will alone form the subgroup 2, and this 0.06 and 0.06 and 0.04 together will form subgroup 3. Now I'll assign values 2, 1 and 0 for subgroup 1, 2 and 3 respectively. Okay, then these two subgroups cannot be divided into subgroups further, so I leave it as it is. Only thing that can be divided into subgroups is this subgroup 3, so we'll go for it. We ultimately want three subgroups. There are three elements, so what we'll do is we'll divide it in such a way, like this 0.06 alone will form subgroup 1, the second 0.06 will form subgroup 2, and this 0.04 alone will form subgroup 3. And then we'll assign a value 2, 1 and 0 for subgroup 1, 2 and 3 respectively. So in Shannon Fano ternary code, we will divide it into subgroups like this and assign three different values in this manner. So after this, we are supposed to draw a tabular column. In first column, you will have to name it as CI, and the second column, you're supposed to name it as LI. Okay, in CI, you're supposed to write the values that whatever you have assigned for the particular symbol probability, and then in LI, it will indicate the length of the CI, that is the code. Okay, so let's see how we will write the CI and LI. So consider the first symbol probability, that is 0.3. Here we have a code word 2. So I'll write CI as 2. And since there is only one bit, I'll name this as LI, that is the length will be equal to 1. Okay, then second symbol probability is 0.3. The code word assigned for that is 1. So I'll write 1 here and the length is 1. Next, third symbol probability. The code word for that is 0 and 2. So I'll write 0, 2, length is 2. Next, fourth, the code word is 0 and 1. So I'll write 0 and 1 and the length is 2. Next, coming to the fifth symbol probability, I have 0, 0 and 2. So I'll write 0, 0, 2 and the length is 3. Next, I have 0, 0 and 1. So I'll write 0, 0 and 1 and the length is 3. And next, I have 0, 0, 0 and the length is 3. Okay, after drawing this tabular column and filling the entities, we will have to find the average length, entropy and entropy of R array units per symbol, as we used to do it for previous problems. So average length is found out using the formula L is equal to summation of I equal to 1 to 7, since there are 7 symbols, and in product of the symbol probability into the length. So the symbol probability is over here and the length is over here in the second column. We are supposed to just multiply. We're supposed to just substitute all the values, multiply and then add all the values. So we will be getting L as 1.56 trinits per symbol, since it is ternary code. And then next, entropy, how we'll calculate is H of S is equal to summation of I equal to 1 to 7 pi log of 1 by pi to base 2. And the probabilities values are over here. Okay, we are supposed to just substitute that and calculate the value of entropy, which we'll be getting it as 2.4491 bits per symbol. Next, entropy of R array units. Since this is ternary, we will consider R as equal to 3. So H3 of S is nothing but H of S by log of 3 to base 2. So H of S we have got as 2.4491 divided by log 3 to base 2. So we'll get H3 of S as equal to 1.5452 ternary units per symbol, and efficiency is given by eta C H3 of S by the average length. So just substitute the values of HT of S and average length multiplied by 100 because we will measure the efficiency in terms of percentage. So after substituting and calculating, we will get the efficiency as 99.05 percentage, which is a very good efficiency value. And then next, how will we draw the code tree? First, we'll draw the root node, and then based upon the codes. So for the first symbol, we have got code as 2, and for second, we have got as 1. So this is the root node, and even in order to get the symbol 1, I'll write 2 over here because the code for symbol 1 is 2, and then I'll terminate branching over here and I'll name it as S1, and code for the symbol 2 is 1. So I'll draw one more branch and name it as 1, and I'll name this node at S2. Next, the symbol 3's code word is 02. So from the root node, I'll draw one more branch. I'll name it as 0, and for S3 it is 02, isn't it? So first 0, I've got it here, and then I'll draw 3 branches at this node also. So I'll name it as 0, 1 and 2. So for 0 and 2, I should be getting S3. So I'll name this node as S3. Okay, and then for the fourth code, for the fourth symbol, the code is 0 and 1. So how will we write that? The first 0, we got it here, and the second one is over here. Okay, so we'll be traversing through in this direction from the root node. So 0 and 1. I'll terminate the branching at this node and I'll name it as S4. And similarly for symbol 5, the code word is 0, 0 and 2. First 0, I got it here. Always we have to start it from the root node itself. So 0, and then one more 0, I got it over here. And next 2. Here also we'll branch it into 3 different branches since it is ternary, and name it as 0, 1 and 2. So fifth code words is 002. So first 0 is here, second 0 is here, and 2 is over here. So I'll name it as S5. And for S6 we have 0, 0 and 1. And similarly for S7 we have 0, 0 and 0. So this is how we draw the code tree. And then in the problem, they've also asked us to find the probabilities of zeros, ones, and twos, isn't it? So the probabilities of zeros and ones and twos are found using this formula. P of 0 is equal to 1 by L into summation of I equal to 1 to 7, since there are 7 symbols, number of zeros in the code for Xi for Pi. So we are supposed to refer this part. Okay, number of zeros we have to count. So we have zeros here, and here also we have 3 zeros, here we have 1 0. So for 0.12 we have zeros twice, and for 0.06 we have 4 times we have zeros, that is over here, and for 0.04 3 times we have 0 over here. So how will we write that is, see, for 0.12 we have 0 twice, so 0.12 into 1 plus 0.12 into 1, or you can write 0.12 into 1 into 2, or 0.12 into 2 directly. And for 0.06 we had 4 times, isn't it? So you can write 0.06 into 2 plus 0.06 into 2, or 0.06 into 4 directly. And for 0.04 we had 3 times 0. So this one is here, second one is here, third one is over here. So I'll write it as 0.04 into 3. So, and the average length value is substituted, and after calculating with the help of the calculator, you will get probability of 0 as 0.03846. And similarly, how many ones are there? How many ones are there? 1, 2 and 3. Only 3 ones for 0.3, 0.12 and 0.06. So probability of 1 is 1 by L, same. Summation of I equal to 1 to 7, number of ones in the code for Xi of Pi. 0.3, 0.12 and 0.06 we had. So we'll substitute all the values, and average length value remains the same. So after you calculating with the help of the calculator, we'll be getting P of 1 as 0.3077. So there are only 3 symbols over here, 0, 1 and 2. We have found out the probability value of 0 and probability of 1. Next we will have to calculate the probability of 2's, right? So since there are only three probabilities, all the sum of these three probabilities will be equal to 1. It should be equal to 1. The maximum value of probability is 1. So we'll write P of 0 plus P of 1 plus P of 2 as equal to 1. And since we have already calculated P of 0 and P of 1, let's substitute that. And from this equation, we'll find out that P of 2 is equal to 0.3077. So this is how we solve a problem under Shannon Fano ternary code. Thank you all.